So WPA, that is wireless protected access 2. So it was started in 2006 and it was officially superseded by WPA 2. One of the most significant changes between WPA and WPA 2 was the mandatory use of AES algorithms and the introduction of CCMP, that is counter cipher mode with a block chaining message authentication code protocol. I believe that's what the full form is. So it was a replacement for TKIP, which was still preserved in WPA as a fallback system and for interoperability with WPA. So currently the primary security vulnerability to the actual WPA2 system is the obscure one, and it requires the attacker to already have access to the secured Wi-Fi network in order to gain access to certain keys and then perpetuate an attack against other devices in the network. So as such, security implementations on the known WPA vulnerabilities are limited almost entirely to enterprise level networks and deserve no practical consideration regard to home network security. But unfortunately, the same vulnerability that is the biggest hole into the WPA armor, the attack vector through Wi-Fi protected setup, that's WPS, remains in the modern WPA2 capable access points. Although breaking into the WPA or WPA2 secured network using this vulnerability requires a total of 2 to 14 hours of sustained effort with a modern computer, it is still a legitimate security concern and WPS should be disabled, and if possible, the firmware of the access point should be flashed to a distribution that doesn't even support WPS, or so the attack vector is entirely removed. So Wi-Fi security history, now you know what it's like. So now what? At this point, you will be either feeling a little smug because you're confidently using the best encryption scheme available for your Wi-Fi access point, or you're a little nervous because you packed in the WEP since it was at the top of your list. If you're on the later, you don't have to worry, but if you have used WEP, you never know, someone might already have gained your access. So before I hit you with a further reading of our top list of Wi-Fi security tutorial, this is a basic list ranking with current Wi-Fi security. The first one and the best one would to go ahead and keep your network secure would be to use WPA2 plus AES encryption. After that, WPA plus AES. After that, WPA plus TKIP or AES again, because TKIP will be the fallback method, or WEP or no network security at all, which I think would be the worst. So ideally, you can go ahead and disable Wi-Fi protected access, Wi-Fi protected setup, that's WPS, and set your router to WPA2 plus AES. So everything on that list is a less than ideal step down from that. Once you get to WEP, your security level is so low, it's about as effective as a chain link fence. The fence exists simply to say, hey, this is my property and no one should enter. But anyone who actually wanted in would just climb right over it. And finally, I will have to teach you about the 802.1x. So, but before I proceed with that, let me explain you something about the WPA2. There are two forms of WPA. One is WPA PSK and WPA2 PSK. So, the Wi-Fi protected access, that's WPA, and the new WPA2. PSK can either be used for both of the encryption method. WPA or WPA2 Enterprise provides coverage for large entities, but it requires a radius server. WPA Personal, that's WPA2 PSK, is an appropriate use for residential and home business settings. So you might be wondering that how does WPA PSK or WPA2 PSK work? With WPA PSK, that's personal security key, you can configure each wireless LAN node, access point, wireless routers, client adapters, bridges, not with an encryption key, but with a rather plain English passphrase that contains up to 133 characters. And using the technology called as TKIP, that's temporary key integrity protocol, that paraphrase along with the network SSID is used to generate unique encryption keys for each wireless network. So these encryption keys are constantly changed. When clients connect, the WPA PSK authentication users provide the password to the verify whether to allow them access to the network or not. And as long as the passwords match, a client is granted access to the wireless LAN. So you might be wondering that when should I go ahead and use the PSK authentication? PSK was designed for home and small network office that do not require the complexity of 802.1x authentication server. Some reasons to use PSK authentication are: PSK is very simple to implement as opposed to 801.1x, 802.1x authentication, which requires a radius server. But your legacy clients might not support 802.1x or the latest WPA standard. Then you might wonder, why would I not use the the PSK authentication? Even if you have a small company, there are drawbacks to using PSK authentication. For example, if an administrator leaves the company, you should reset the PSK key. This can become quite tiresome and it will be skipped, obviously, because you will not go ahead and actually go ahead and change the keys every day, because you will actually get fed up one or the later point of time, and because you need to go ahead and reconfigure. Let me give an example. You are here to go ahead and learn this tutorial today about wireless hacking. But you might be wondering that, okay, this is just, you can say, as PowerPoint presentation that I'm teaching you right now, and you don't actually have anything to learn like actual hacking. But the thing is, in order for you to know how exactly wireless hacking works, you need to know what are the encryption and decryption protocols are and how exactly they work. Else, you will be similar to the administrator who just goes ahead and keeps his password as abcd@123, thinking that he has a total of 8 characters which are different, and he may probably keep A as capital and D as capital, and he will think that he has a good security because he has capital letters, lowercase letters, and different characters and numerics as well. But no, that is one of the most easiest to crack. Similarly, just going ahead and cracking a Wi-Fi is not. So if sometime later on, if someone gains access to your Wi-Fi, you will know that he's not a noob, because people who are new to hacking cannot go ahead and crack a Wi-Fi, or not as even a single noob can go ahead and crack a Wi-Fi password, especially WPA or WPA2, because it requires intense knowledge about how the encryption and decryption protocols works. So coming back to our point, if an administrator leaves the company, you should reset the PSK key, and this may be skipped by a lot of administrators. If one user is compromised, even if one, then all the users can be hacked. PSK cannot perform machine authentication the way that IEEE 802.1x authentication them. Keys tend to become old because they are not dynamically created for users upon login, nor are the keys rotated frequently. You must remember to change the keys and create keys long enough to be a challenge to hackers, or to be much irritable for people to go ahead and change them every now and then. So if you want me to be more precise, a proper way of creating a key is something like would be typing A8GHIP0. No, not this won't suffice. So this doesn't make any sense, right? Yes, that's why. And this should be how your password should look like. Any random set of numbers, but you should make sure that you don't have any kind of specific word that can make sense, because if that does, then it will make 99% more sense to the computer, and it will be able to crack your password. So to be more precise, this is how your password should look like. And this I don't think that these people can go ahead and crack these kinds of password, but still there's another way that is called social engineering, which you already know. And PSK is subject to brute force key space search attacks and dictionary attacks. And one more thing you can do is, let's say for example, you just go ahead and type random passwords like this, and this is an example. And one more thing, instead of just keeping these, you can also go ahead and type a space. Yes, space also tends to be a password. And normally people go ahead and keep the space at the start or at the in between, but no one actually goes ahead and thinks of space in the end. You can have multiple spaces in the end, and you can type something like, not ASD because it's quite easy to understand, so this. And if you have this password in WPA2, I can guarantee you with anything that no one will be able to crack, except until it is social engineering. Even I think you won't be able to remember this password yourself, no matter how much times you go and actually try to remember them. Just a quote. So WPA2 PSK uses a more advanced encryption type. Additional processing power is required to keep the network functioning at full speed, and wireless networks that use legacy hardware for access point and routers can suffer speed reductions when using WPA2 personnel instead of WPA, sorry. And especially when several users are connected or large amount of data is moving through the network. Because WPA2 personnel or PSK is a new standard, firmware upgrades can also be required for some hardware. Normally you won't be requiring that, but still it is much better than WPA exclusively. How is WPA encryption different from WPA PSK, you might be wondering? The primary difference between WPA and WPA2 PSK are the encryption ciphers used to secure the network. WPA can use only the encryption cipher, that's TKIP, whereas WPA2 PSK can use TKIP. But because TKIP security keys are less secure, WPA2 protocol usually uses the AES encryption method. And AES uses a much more advanced encryption algorithm that cannot be defeated by tools that overcome the TKIP security, and making it a much more secure encryption method.